All right, you guys, hey, welcome to chapter 1. Like I said in class, this video is optional, just in case you are having trouble with the very first Math Excel assignment. That means you may have forgotten some of your geometry. Some of you were in regular geometry, some of you were in honors. It has been a long time for a lot of you since you've seen these angle pairs and stuff, so I wanted to briefly go over this. You can pause the video and copy this stuff down into your notes if you'd like. If I go too fast, but I'm going to breeze through these to give you an idea of what all these vocab words are, and then I'm going to move on. So first vocab word we have is vertical angles. So vertical means that they like form V's kind of. So see this angle 1 right here, it's forming a V, as you can see, with angle 4. So I just put one example here, although there are numerous examples of vertical angles on here. Another one would be angle 2 and angle 3. See how they're formed when you cross two different lines together? A bunch of different pairs of vertical angles are formed. Another option would be 5 and 8. Another option is 6 and 7. So those are vertical angles. Think about the V's. Linear pairs, pretty self-explanatory there. They're two angles that come together to form a line. So angle 1 and angle 2 are forming a straight line when you smush them together. Angle 1 and angle 3 are forming a straight line when you smush them together. Angle 3 and 4, angle 2 and 4. We also have 4 more down here. We have 5 and 6, we have 6 and 8, we have 7 and 8, we have 5 and 7. Important thing to note about linear pairs is that when you add them together, they form a straight line, aka 180 degrees. Vertical angles, something important to note that I didn't mention earlier, is that they are congruent, they're equal. So like these are two acute angles, 2 and 3, 1 and 4 are two obtuse angles, and they have the same exact measure. A transversal, I'm sure you're maybe having terrible flashbacks from geometry class about what that word means, but a transversal is a line that intersects two parallel lines. So here's my two parallel lines. The transversal I highlighted here in blue, see how it is touching both lines? It's forming 4 angles up here and it's forming 4 angles down here. So it's cutting through two parallel lines. That is called a transversal. We have alternate interiors. I'm sure you remember hearing about those in geometry class, but the interior of the two parallel lines is in here. That's inside the two parallel lines. So any kind of interior pair that we're talking about is going to occur in here. And alternate means alternate or opposite sides of the transversal. So we're looking interior and we're looking opposite sides of this line. So alternate interiors, one example would be 3 and 6. Also, those angle measures are congruent. They look equal, and they are when we have parallel lines. And also 4 and 5 is another option. They're both interior angles, and they are on opposite sides of the transversal. One's on the left, one's on the right, if you want to think about it that way. Alternate exteriors, pretty self-explanatory after doing alternate interiors. 1 and 8, they are outside of the parallel lines, and they are on opposite sides of the transversal. Another option is 2 and 7. So 2 and 7 are here. Those are on opposite sides of the transversal, and they are outside of the parallel lines, so exterior. And then you can probably understand same side interiors, same side exteriors. So same side interiors, only one option here, 4 and 6. Or the other option would be 3 and 5, two options as well. So 3 and 5, 4 and 6. Those are on the same side of the transversal, so 4 and 6 are both on the right-hand side, 3 and 5 are both on the left-hand side, and they are inside the parallel lines. Same side exteriors, we have 2 and 8 as our first option. They're both on the right of the transversal, and they are outside the parallel lines or exterior. Another one is 1 and 7. They're on the left-hand side of the transversal and outside the parallel lines. Corresponding is the one that most people tend to forget. That to me means same position. And so if you look at this group of 4 angles up here, and I pick angle number 1, that is in basically the top left of my group of 4. And so I'm going down here. What else is in the top left up here? That would be angle 5. Those two are in the same position, angle 1 and angle 5, same position of the group of 4. So that's my first option here. Just because that one's harder, I listed another option so you have something else to compare to. Let's look at angle 3. It's in the bottom left. Well, what's in the bottom left down here? That would be angle 7. See how 3 and 7 are in the same position in their group of 4? Those are corresponding, and those are also equivalent. What I forgot to say about same side interiors and same side exteriors, just in case you forgot also, 3 and 5, do they look like they're equal? Angle 3 looks like an acute angle, and angle 5 looks like an obtuse angle. So they're definitely not equal, but they are supplementary. They add up to 180 degrees. Same thing over here with 4 and 6, supplementary. This one's obtuse, this one's acute. Same thing with 1 and 7, one's acute, one's obtuse. In the case of having parallel lines, that means they're supplementary. And also with 2 and 8, supplementary. One's acute, one's obtuse. Last thing to remember, and this is probably something that you learned before geometry class, but another thing to keep in mind here is that all angles in a triangle always add up to 180 degrees. Okay, there are a couple more things to be discussed. I have a lot of these snips from our textbook here so that you have less writing to do and you have more of a visual to look at. But an acute triangle, a right triangle, an obtuse triangle, again, pretty self-explanatory. About the angles here in an acute triangle, all the angles are acute versus having one right angle in a right triangle versus having one obtuse angle in an obtuse triangle. So you will have to match these up in the Math Excel assignment also. And then the vocabulary in terms of sides, if it is equilateral, that means all the sides are equal. You can see those tick marks there. Every single side is the same length. Isosceles is the word for when you have two sides that are the same, and scalene is the word for none of the sides are the same. When you have similar triangles, going over here, here's an example of what two similar triangles are. They're obviously not the exact same, so we're not going to refer to those as congruent triangles. They are similar, meaning they're kind of the same, but you can obviously see that one of them is bigger than the other. However, the angles are congruent, and the corresponding ones, that is. So for example, angle A has a double swoop, angle P also has a double swoop. Those angle measures, the degrees, are the exact same. Same with B and Q, and then obviously C and R, those are right angles. So all those angles match up and they are congruent. Now, are the side lengths the exact same? No, but there's a fancy word for it. They're proportional. That means when you make fractions out of the side lengths, let's say this was 2 feet long and this was 3 feet long, we would make a fraction 2/3, and that would be the same fraction as if I would compare this side to this side. It would reduce to 2/3, and this one would reduce to 2/3. That's what proportional means, if you remember that. I do have a couple example problems that I want to go through here. You will have to do this in your Math Excel assignment as well. I'm going to zoom in so you can read a little bit better. And this first example, you have to think to yourself, okay, how am I going to set this thing up? I know I can solve algebraic equations, but are these angles equal? This one and this one, or is there something different about it? So look at this angle. It is acute, and this one is obtuse. So we are definitely not going to set these equal to each other. What we are going to do is add them together and set them equal to 180 degrees. These are linear pairs. This is a linear pair. So here's a perfect example. These are two angles that form a straight line when you put them together. So that's going to be my equation, and that's how I'm going to solve it. I'm just going to do that real fast. You can follow along or pause the video if I'm going too fast. So I'm taking the first angle and adding the second angle and equaling it to 180. I'm just going to combine like terms. So I have 8x and 20 equals 180. That means 8x equals 160, and that means x equals 20. So what you will have to be careful of, I will warn you about in the Math Excel assignment, is that sometimes it asks for what's x equal to. Other times it'll say what are the two angle measures equal to. So you might have to plug in this 20 here. So 5 times 20 is 100 plus 15 would be 115 degrees here. Or you might have to plug in the 20 here. 3 times 20 is 60 plus 5 is 65. And hey, look at that, magically, this plus this does equal 180 degrees. So it's kind of self-checking. So just keep that in mind. Make sure you're answering the question in Math Excel, because sometimes they'll ask for x and sometimes they'll ask for an actual degree measure. How about this one? Do these two angles added together equal a straight line? No, they do not, but we have this box here, which I'm sure you remember means they equal 90 degrees when you add them together. So I'm going to breeze through that one real fast. You can pause the video and copy this down. So here's our answer for that one. You take your two angles, And in this case, we're not adding them to 180, we're equaling them to 90 because they are forming a right angle, hence the box. Gives us x equals 13 when you work through the math. Keep in mind you may have to answer what is the measure of this degree and what is the measure of this degree, or just solve for x. Okay, this last one over here is a example of those angle pairs that we refreshed our memories on up above. And so think to yourself, first of all, what are these called? Here's my transversal. These are my two parallel lines. This angle and this angle are on opposite sides of the transversal, so alternate something. They are not in the interior of the parallel lines, they are on the exterior. So these are alternate exterior angles. A, E, A's. And they're both obtuse, and in this case with these parallel lines, that means they are congruent, so we can equal them to each other. They're both obtuse, they look obtuse here. It's not the case of one being obtuse and one being acute versus which would mean we're setting them equal to 180 when we add them together. In this case, they are equal, so you can put a giant swoop here and a giant swoop here, and I'm going to solve our equation. And here's what that one looks like. After you solve them, set them equal to each other, we get x equals 28. Again, make sure that you answer the question. It might be asking for what are the degree measures or what is x. So I do have two more problems to go over here. Again, these are still geometry review, but you may have forgotten a lot about this. How do we solve for x in this case? A very common mistake is to go, oh, the relationship is 150, that means half, so if this is 120, this is 60. That is incorrect. So what I encourage you to do, although it does take a few minutes, is to actually draw the triangles separately. This will help you not confuse what you're doing and make a silly mistake like I just explained. So this is 100 and this is 50. My x is over here, but what is this? It's not 120, is it? This entire side is actually 220. And so that's going to help us set up our proportions. So we need to set up ratios here, and we need to compare sides. So the 50 and the x go together, so I'm going to make a ratio out of that. 50 over x, and my other two sides are 100 and 220. So I'm going to set up that as well. 100, 220. And so there's a couple different ways that you can attack this. Also, I could have set up my ratios differently. I could have done x over 50 and 220 over 100. I could have done that. It would have worked out. I could have done 50 and 100 and x and 220. There's a lot of different ways to set up the proportion, but at the end of the day, what you're going to do is cross multiply to solve. There is a shortcut in this one, and it only works if you notice a pattern. But notice how to get from a 50 to 100, you just multiply by 2. So what times 2 gives you 220? Well, that would mean that x equals 110. Also, you could cross multiply that way. This is just a trick if there is a relationship. So the problem with that is, what if this were like 99? Then it wouldn't have been easy to figure that out. I would have had to do the long way. But if you're going to cross multiply, do 100x equals whatever 50 times 220 is, and those are really big numbers, but that's okay. You would still end up with 110. All right, last problem, a word problem. And I know a lot of you are probably like, a house is, oh, screw it, I'm going to guess and just move on. No, these are actually pretty fun, I think, because I like to draw little pictures, even though I'm terrible at art. A house is 15 feet tall. Okay, I'm confused already, so I'm going to draw my little house. 15 feet tall. Good. The house casts a shadow. Interesting. So you can actually picture the shadow right out here, and it is 40 feet. Weird. The same time as a nearby building, which has a shadow of 300 feet. So we've got this building, which obviously is taller. You can put some windows on there if you want to, whatever. But it has a much longer shadow of 300 feet. Find the height of the building. So where's the x go? The height of the building? Right here. And if you wanted to, you can make little triangles out of this, although it doesn't matter, but that's kind of the idea of the whole problem, is that these are just similar triangles. So again, what we have to do is set up a proportion. So I'm going to just do, first thing I think of, 15 over x equals 40 over 300. Very simple. And so that's what my proportion looks like. I'm not exactly sure what 15 times something gives me 40, so I'm going to do the long way. I'm going to do 40x equals, and I'm going to cross multiply this way, 15 times 300, which is actually a pretty big number. It is 4,500. Divide both sides by 40, and you actually get a decimal here. And I know a lot of us hate decimals and think that we've done something wrong when we come up with a decimal, but it is okay. Sometimes we get decimals. Okay? So that is that. That's your blast from the past in terms of geometry review. Thanks for watching. If you have any questions at all about any of this, shoot me an email or see me tomorrow, and I'll address your questions in class. Have a good night, guys.